Hello everyone. So now we are going to start objective type question part 3 for class 12 physics. Chapter name is atom. This topic is important for the CBSE NEET as well as for the IIT JEE examination. So let's begin this topic. The first question which we are taking, that is Bohr's atomic model assumes the nucleus is the finite mass and is at rest. Electron in a quantized orbit will not radiate energy. Mass of electron remains constant. 1, 2 and 3 are correct. So this is the right option for that. Next question is, an electron with kinetic energy E electron volt collide with an hydrogen atom in ground state. The collision will be elastic. Now the first option is for all values for E. For E is less than 10.2 electron volt. Third, for E is less than 30.6 electron volt. Only E is less than 3.4 electron volt. The correct answer for this question is option 2. Next question. The ratio of magnetic dipole moment to angular momentum in a hydrogen-like atom is E by m, E by 2m, E by 3m, 2E by m. So, the correct answer for this question is, firstly we see the solution. Magnetic moment of electron in the nth orbit is Mn is equals to EHn by 4 pi m. So angular momentum L is equals to NH by 2 pi we can derive from here. M by L is equals to E by 2m. So from here we can say the correct option for this question is second. Next question is for electron moving in an nth orbit of the atom. The angular velocity is proportional to n 1 by n cube, 1 by n cube. Let's see the solution. Omega n is equals to 8 pi square k square z square e to the power 4m by n cubes h cube. So omega n is equals to 1 by n cube. From here we can say the correct option is option 4. Next question is, atomic hydrogen is excited to the nth energy level. The maximum number of spectral lines which it can emit while returning to the ground state is 1 by 2 n nth minus 1, 1 by 2 n times n plus 1, n plus 1, n minus 1. Let's move with the solution part. So 1 by 2 n minus 1 is the correct answer. The radius of hydrogen atom when it is in its second excited state becomes half, double, 4 times, 9 times. Students, let's see the solution part. We know that Rn is equals to n square, h square, 4 pi square, e square, k times zn. So, what we are going to do? We just put this value and we get like Rn is proportional to n square. So, for n is equals to 1, for ground state we can say n is equals to 2 for first excited state. N is equals to 3 for second excited state. So for second excited state, the value of n is 9 times. How we can calculate it? Simply R1 by R3. We just put this value and get the value for R3 in terms of R1. I hope you understand, students. Next question is, in the lowest energy level of a hydrogen atom, electron has the angular momentum pi by h by pi, h by 2 pi, 2 pi by h. So let's move with the solution part. L is equals to nh by 2 pi. From here, we can say n is equals to 1 for lowest energy level. L is equals to h by 2 pi is the right answer. Next is ionization energy of a hydrogen like ion A is greater than that of another hydrogen like ion B. Let a small r, u, e and L represents the radius of the orbit, the speed of the electron, energy of the atom and orbital angular momentum of the electron respectively in the ground state. Options are Ra is greater than Rb, Ua is greater than Ub, Ea is greater than Eb, or La is greater than Lb. Let's move with the solution part, students. So E ionization is equals to, we know that 2 pi square k square z square e to the power 4 m by n square h square. From here we can say that E ionization is equals to Vn times pi k z e square m by nh. So E ionization is directly proportional to V. Whereas Ea is greater than Eb, it's given. So Ua is greater than Ub. Hence, the correct option is option 2. Next, on decreasing principal quantum number n, the value of a small r and v will be decrease, increase, r will be increase, v will be decrease, and r will be decrease, but v will be increase. So students, we know that Rn is equals to n square h square by 4 pi square kz square by n. So Rn is proportional to the directly n square. And Vn is equals to 2 pi kz square by nh. So from here, Vn is inversely proportional to the n. Hence the fourth option is the correct. Next question is, if the radius of the first Bohr orbit is small r, then radius of the second orbit will be 2r, r by 2, 4 times r, or under root 2r. So the solution is Rn is equals to, we know, n square h square by 4 pi square kz e square m. So Rn is directly proportional to n square. Hence R1 by R2 is equals to 1 square by 2 square, which is equals to R by R2 equals to 1 by 4. Hence 4R is equals to R2, which is the option number 3rd. Next, according to the Sommerfeld, an electron revolves around a nucleus in circular orbit, elliptical orbits, hyperbolic orbit, parabolic. So, this is the second option, elliptical orbit. Next, if En and Jn are magnitudes of a total energy and angular momentum of electron in the Bohr orbit respectively, then E is directly proportional to J square, E is indirectly proportional to 1 by J square, E is directly proportional to J, and E is inversely proportional to the Jn. Now move with the solution part, students. We know that Jn is equals to nh by 2 pi. So from here En is equals to, we know, minus 2 pi square k square z square e to the power 4 m by n square h square. From here we can say En is equals to 1 by jn square times minus kz square e to the power 4 m by 2. Here we can say E is directly proportional to 1 by jn square. So the correct option for this question is 2. Next question we have, according to the classical theory, the path of the electron in the Rutherford atomic model is straight line, spiral, circular, parabolic. The correct option is spiral. 14th question is, the hydrogen atom will be in the ground state if its electron is in AD energy level, the lowest energy state, the highest energy state, the intermediate state. Now move with the solution part. So, if the electron in the lowest energy state then hydrogen atom is said to be ground state. So the correct option is 2. An electron makes transition from n is equals to 3 to n is equals to 1 state in the hydrogen atom. The maximum possible number of photon emitted will be 1, 2, 3, 4. Fourth is 6. So the correct option is 3. Next, the visible region of a hydrogen spectrum was first studied by Lyman, Balmer, Pfund, or a Brackett. So the correct answer is the Balmer series. Rydberg constant is same for all element, different for different element. A universal constant is different for a higher element but same for heavier element. So the correct answer is different for different element. The radius of the first orbit n is equals to 1 will be minimum in doubtfully ionized lithium, singly ionized lithium, helium, and deuterium atom, hydrogen atom. Solution we have Rn is equals to n square h square by 4 pi square e square kzm. From here we can say R is directly proportional to 1 by Z. So the correct answer is a doubly ionized lithium. Question number 19 is regarding Bohr's model of hydrogen atom. Which of the following statement is true? The acceleration of the electron in n is equals to 2 orbit is more than that in n is equals to 1 orbit. The angular momentum of the electron in n is equals to 2 orbit is more than that in n is equals to 1 orbit. The kinetic energy of electron in n is equals to 2 orbit is less than that in n is equals to 1 orbit. All the statements are correct. Only A and B are correct. Only B and C are correct. Or only C and A are correct. The correct answer for this question is, students, option 3. Let's see the solution. That understand the step-by-step process. L is equals to NH by 2 pi. We know from here that L is directly proportional to the N. And kinetic energy is equals to, we know, 13.6 Z square by N square electron volt. So from here we can say kinetic energy is directly proportional to 1 by N square. Hence the correct option for this question is 3. Moving ahead. If the potential energy of the electron in the first allowed orbit in the hydrogen atom is E, its ionization potential energy is minus E by 2. Peak kinetic energy is minus E by 2. Total energy is E by 2. None of these. So, A and B are correct. A, B and C are correct. A, C and D are correct. And the last, B alone is correct. Students, let's move with the solution part. So, we know that UN is equals to E, which is equals to minus 27.2 by N square times Z square electron volt. Kinetic energy is equals to 13.6 by N square Z square electron volt. So from here we can say this value comes equals to minus E by 2. So total energy En is equals to 13.6 by N square Z square electron volt, which is equals to E by 2. So E ionization is equals to 13.6 by N square Z square times electron volt, which is equals to minus E by 2. Hence the correct option is 2. Next question is, according to the Bohr's theory of hydrogen atom, for the electron in nth allowed orbit, linear momentum is directly proportional to 1 by n, and radius is directly proportional to n. Kinetic energy is proportional to 1 by n square, or angular momentum is proportional to n. So let's see the solution of this question. We have these options. A and B are correct. A, B and C are correct. A, C and D are correct, or B alone is correct. So, move with the solution part, students. L is equals to NH by 2 pi. From here we can see that L is directly proportional to N. And Rn is equals to N square H square by 4 pi square E square KZM. From here Rn is directly proportional to N square. So kinetic energy 13.6 Z square by N square electron volt, So kinetic energy is proportional to 1 by n square. Hence the correct option is our 3. Next question. When a hydrogen atom is raised from the ground state to the unexcited state, both kinetic energy and potential energy increases, both kinetic energy and potential energy decreases, potential energy increases and kinetic energy decreases, potential energy decreases, kinetic energy increases. So the solution part is Un is equals to, we know, minus 27.2 by n square z square electron volt. So Un is directly proportional to minus 1 by n square. And kinetic energy is equals to 13.6 by n square z square electron volt. So kinetic energy is directly proportional to 1 by n square. Hence the correct option is 3. Next, during which of the following transition the energy change will the greater? N is equals to 2 to n is equals to 1, n is equals to 3 to n is equals to 2, n is equals to 4 to n is equals to 3, or n is equals to 5 to n is equals to 4. So the correct answer for this question is the first. Next question. In Bohr's model of a hydrogen atom, the radius of a nth orbit is proportional to n square. The total energy of the electron in nth orbit is inversely proportional to n. The angular momentum of the electron in an orbit is an integral multiple of h by 2 pi, 2 lambda. Or the fourth is the magnitude of potential energy of electron in any orbit is greater than kinetic energy. So A and B are correct. A, B and C are correct. A, C and D are correct. Or B alone is correct. So let's move with the solution part, students. Rn is equals to n square h square by 4 pi k z e square m. Or Rn is directly proportional to the n. So Un is equals to 27.2 by n square z square electron volt. Kinetic energy is equals to minus 13.6 n by n square z square electron volt. So from here we can say Un is greater than kinetic energy. From here we can say the correct option for this question is 3. Next question is, which of the following statement is correct? The de Broglie wavelength of an electron in the first of Bohr hydrogen is electron to perimeter of the orbit. The second, in the case of a hydrogen atom, the energy required to remove an electron from the fourth orbit is 0.85 electron volt. Next is, so A and B are correct. A alone is correct. A and B are wrong. Fourth, B alone is correct. Let's move with the solution part, students. So here we know that Rn is equals to n square h square by 4 pi e square k z m. For first orbital, n is equals to 1. And for a hydrogen atom, we know that like R is equals to h square. If n is equals to 1, z is equals to 1. So R is equals to h square by 4 pi square e square k m. And perimeter 2 pi r, so according to that, h square by 2 pi e square km. De Broglie wavelength lambda is equals to h by p, which is equals to h by mv. H by m times the value of v is 2 pi kz ae square by nh. So it's equal to nh square by 2 pi e square kmz. If n is equals to 1, z is equals to 1. So 2 pi r is equals to h square 2 pi e square kz. From equation 1 and 2, what we can say that perimeter is equals to 2 pi r. And E ionization, which is equals to 13.6 z square by n square electron volt. So n is equals to 1, n is equals to 2 here we can say, and z is equals to 1. So we just got the value 0.85 electron volt, which is an option 1. Next question, which one of the series of hydrogen spectrum is in the visible region. Which one of the series of a hydrogen atom is in the visible region? The options is Lyman series, Balmer series, Paschen series, Brackett series. The correct answer is Balmer series. In the Rutherford scattering experiment, what will be the correct angle for alpha scattering for an impact parameter? 90 degree, 270 degree, 0 degree, or 180 degree. So, students, we know impact parameter is equals to ZE square cot theta by 2 by 4 pi epsilon naught into 1 by mv square. After solving a bit, we get the value 180 degree because we get the value v is equals to 0. So now next question is energy magnitude of linear momentum and orbital radius of an electron in hydrogen atom corresponding to the quantum number n, e, p and r respectively. According to the Bohr's theory of a hydrogen atom, EPR is proportional to 1 by n, P by E is proportional to n to the power 0. ER is not constant for all orbitals. PR is proportional to n. A and B are correct. A and C are correct. A and D are correct. B and D are correct. So the correct answer for this question is 3. Now let's move with the solution part, that how it's possible. So EPR is equals to minus 13.6 Z square n square MVR. From here we can say that minus 13.6 Z square by n square into m into 2.2 into 10 to the power 6 Z into R naught n square Z. So minus 13.6 Z square by n square into m, the value of V 2.2 10 to the power 6 Z by n, and the value of R naught times n square by Z. So this value is equals to EPR proportional to 1 by n, and here PR is directly proportional to n. So from here we can say the correct option was that. Next question is, the frequency of the first line in the Lyman series is a hydrogen spectrum is F. The frequency of the corresponding line in the spectrum is F of doubly ionized lithium is F, 3F, 9F, 27F. Let's move with the solution part. Vn is equals to 4 pi k square z square e to the power 4m by n cube h cube. So from here, Vn is directly proportional to the z square. F by F1 is equals to 1 by 3 whole square, which comes the value F1 is equals to 9 times of F. So the correct option is 3. Last question, an hydrogen atom and a lithium plus ion are both in the second excited state. If lithium H and lithium hydrogen and lithium ion, their respective electronic angular momenta and EH and ELI, their respective energies, then LH is greater than Li, EH is greater than Li, LH is equals to Li, and LEH is less than ELI. LH is equals to LLI, and EH is greater than ELI. LH is equals to LLI, and EH is less than ELI. So let's move with the solution part, students. L is equals to NH by 2 pi, where as we know that L is directly proportional to the N. And for second excited state, we know N is equals to 3 for both, so LH is equals to LLI. From here, E is equals to minus 13.6 Z square by N square electron volt, so E is directly proportional to the Z square. For H2, Z is equals to 1, for Z square is equals to 1. So for Li is equals to Z is equals to 3, Z square is equals to 9. And EH is less than ELI. So the correct answer for this question is 2. I hope students you understand the concept behind the each and every terms of the question. If there is any problem, any doubt, you can ask in the comment section. Till that, everyone, take care and thank you for watching this video.